So what we've got here is something that I hope most of us have had a look at so far. These are commands that we issued in SQL in order to create some 5 tables. So just to sort of go over them again to make sure that we all understand what's going on there. We do have this command called drop table. We use that to delete a table. It's good if we want to start off with a clean slate. It's not the type of thing that you would do every day with your working database, because if you have files that have data in them, that data is going to be lost, right? Because the drop table is going to drop it out of the database. So you would keep a backup of it somewhere. Databases are a lot about backup. In a way, I'm getting you to do that in the way that I'm asking you to approach this part of the course, because we're working using an editor and we save our commands in the editor, which is a way of saving things. Now, it's not a very efficient way of saving data in an insert statement. That's not the way that you would do it. You would do a direct backup from the tables on the database. But for our purposes, for what we're doing, which is just learning about how to create the tables, what we got here is we have this scripting, and that's something that you need to sort of come to grips with too. That's also what I was trying to teach you here. The idea of scripting, which is that you can have multiple commands, one after the other, saved in a file, and then that file you can actually execute that file. Now, because this is actually an SQL file, we could execute this on a server, but what we're doing is we just copy the contents of it and put that into our server. Now, these commands, we drop a table. The if exists, some people were a bit caught up by that. If exists is a test, because if you try to drop a table that doesn't exist, you will get an error. So by saying if exists, only if the table exists will it be dropped. So if it doesn't exist, you won't get the error. Right now, the next thing that we did is we did a create table command. Create table, we give the table name, and then we list all of the fields in the table, and we have to list the type of data that is with those fields. And one of the fields has to be a primary key if this is going to be a relational database with more than one table. If we only had one table, we might be able to get away with this one. To be honest now, actually, to fit the theory of a relational database, we must have a primary key for each table. Now, I've used that term, relational database. What does that mean? Relational database means a database that is made up of tables. Tables is something that is intuitive to people. That is, we look at tables and we know what they mean. It's not the most efficient way of storing data on a computer. And so it's not the first way that data was stored on a computer. The first databases were network databases. And the data was stored by just pointers between the different parts of the data. The relational database, that, however, was designed to be more intuitive so that you wouldn't have to spend 5 years at university. I'm exaggerating a little bit, but you wouldn't have to have a degree in computer science in order to write a program to put data into a database. Now, you may find this a little bit hard, but believe me, it's not hard at all compared to working with a network database, which is what they had before the relational database. So the idea of the relational database was actually so that, and the SQL language was actually so that we could have a much quicker uptake of it. People that didn't have a lot of IT skills could very quickly start writing SQL codes and working with databases. And you'd find that in businesses throughout the 1980s and 90s, when SQL became very popular. I mean, the old bank systems before 1990, and some of them even into more recently, they were all written with COBOL programming language and network databases. And yeah, you had to be a real IT nerd to sort of work on those. Now it's with SQL, you can have managers that can actually write a select statement. You guys spent like 2 hours and you're already able to write select statements. do that in the old style databases would have been a lot harder. All right, so what we do is we create the table. The table is going to have columns with field names. These are the field names for each of the columns, that are in the create command. Then we insert into those fields. We don't have to insert into all of them, but we can pick. But that we do values, and then what we end up with is a two-dimensional table. And what I'm going to do is I'm actually going to go and create this. You've seen this, so this is just repeating what we've done before, but I'm going to go and sorry, I should go and select all and then copy. Let's refamiliarize ourselves with what we're working with, which is the, and my apologies here because Zoom is in my way. But if we go to SQLite online, and we don't need to log in or anything else, but what we do have to do every time we're using this is we do have to select which kind of database management system or which we want to use, and we're going to use MSQL. They're all SQL, but this is, oh, look, I've got that one. So let's drop all these tables. Drop table, and well, actually, I don't need to, because if I've written this code properly, it's got a drop table at the start of every one anyways, right? So let's see if that'll run. Yes, it does. And so now we have our tables. Let's look at each of these tables now and see. Now, this is the structure that was prescribed in the create command. The create command created these fields with, and you can see that the types are there just exactly as we did with the create command. Now, actually, what's really cool in SQLite is I can double click on the customer and it shows me the actual contents, and it shows me the command that I would have to do to get those contents out, which is, of course, select star from customer. In other words, show all the data. Now, this is what I meant a minute ago, is the way that relational databases work is it works with tables. We see the table, right? It's a two-dimensional thing. We've got columns and we've got rows. So the columns are going to be our fields. We refer to those as attributes. So a customer can be defined by all of these fields within the customer table. So a customer has a name, customer has a street, customer has a city, state, etc. These are all attributes of the customer. So when you go into database design, you would have to sort of learn about that. Now, for each customer, they only have one customer ID that defines that customer. That is the unique identifier, and that's here. This one here, though it's showing red as a number, it's a unique identifier. That means for the customer number 148, there's only one customer that can ever be described by that in this database, and that's Alf's Appliances. Now, it's possible that you could have more than one customer living in the city of Fillmore. We can see that it's certainly possible that we have more than one customer being in the state of Florida. It seems like they're almost all in the state of Florida. So these fields here don't have any uniqueness about them. All right, so anybody could have the same value on each of these, right? As we see with the rep number, there's no uniqueness there, right? We've got a couple of people there that have the rep number 35, a couple 65. Now, sorry guys, but I am sort of getting a bit of feedback coming through there. I'm just muting you guys, and if you need to talk, put your hand up, or else you can unmute yourselves. So anyways, and maybe you'd like to speak now. I mean, maybe you'd like to tell me if this makes sense. I think it does. I can't be inside your head, so I don't know what you're thinking. But to me, when I first saw this in computing, it kind of made sense. It's like the reports that you read, even in the newspaper. People can generally look at this and make sense out of it, and that's the actual sort of key, the beauty of SQL. It kind of looks like a spreadsheet, doesn't it? But it's actually a table. It's somewhat more complicated than a spreadsheet. So there's our customer. As I said, we have the unique identifier, this field here. Now the rep number, I want to talk about that for a minute too. The rep number And I'm trying to be responsive to what the student asked me a minute ago, which is, please don't give us another assignment today. And so instead, I'm trying to just give you some background about the database. And I think this is, maybe I should have done this before. Yeah, anyway, so we'll do it now. The rep number, this number shows up somewhere else, doesn't it? It actually shows up in the sales rep table. In the sales rep table, there's a rep number, and these, in fact, these exact numbers show up in the rep number in the rep table, because of that, we use this part of the table, the rep num key, because this is a key, but it's a special kind of key called a foreign key. So the rep number is used to identify the rep in the rep table. So let's look at the sales rep table. I'm going to open up it. And so you see that the rep numbers, do you see those rep numbers? Don't they look familiar? They're the same rep numbers that we saw in the customer table. So these things form a link between the tables. We call those links relations. That's why this is a relational database. Relational database is made by a bunch of tables. Maybe you can have many tables, but typically, more than one anyways, tables that are related to each other by their keys. So in this table, this is a unique identifier. In this table, only one rep has the rep number of 20, and that's Valerie Kaiser. And so every time the 20 appears, that's only about Valerie Kaiser. It can't be about anybody else. When I go to the customer table, only one customer has the ID of 148, and that is Al's Appliance. However, the rep number 20 shows up 3 times. That's because 3 customers are represented by the sales rep whose ID is 20, and that was Valerie, what was her name? Valerie, whatever. So let's go back and have a look at that again. Who was that? Valerie Kaiser. Interesting name, German name. So Valerie Kaiser has 3 customers. See here, there's only one Valerie Kaiser, and she's represented in the sales rep table. But if we look at the customer table, we can see that every customer has a sales rep. Every customer only has one sales rep, but the sales rep may have multiple customers. And so that requires that we're going to link those tables together. And so that's what we do there. So we could actually link these tables together by making the number of the representative in the customer table, setting it to the number in the representative table, a sales rep table. And then that way we could get the data from the sales rep. Go back to the sales rep. Supposing I wanted to know what is the name of the sales rep for the customer whose name is, who lives in the city of Fillmore. Okay, so we actually have more than one customer in the city of Fillmore. Now, the first customer in the city of Fillmore has a rep of 20. Oh, well, it looks like both customers in the city of Fillmore have a rep of 20. So they both have the same rep, 20. We could say for the customer Al's Appliance and the customer Klein that live in the city of Fillmore, the name of their sales rep is Valerie Kaiser. Now I can do that by looking at the tables. Actually, SQL will do that for us kind of automatically. We can write a query to do that. Let's look some more at some more of the tables here. So now it's just familiarizing with the tables. I listened to the student, said, please don't give us more work. So what I want you to do is pay attention and let's get used to these tables so we're ready to do the next exercise. So what we have here is we have an order, and the order has a couple of fields, right? We got order must happen on a date. It's got a unique identifier, which is the order number. So that's the primary key. What we also have in there something about the customer. So in other words, that tells us just by looking at this that orders are related to customers. Or another way of saying that is, obviously, customers make orders. A customer makes an order on a particular date. Because the same customer can make more than one order. How can we see that? Because here's the same customer, customer 148, is making an order on this date and then making another order on another date. Oh, actually, no, it's not the same date. This is the 20th. This is the 23rd. So the same customer can have multiple orders, and each of those orders will have its own unique identifier. But the customer can, could be on different dates. It looks like we only have one. We don't have multiple dates of customer. Well, the way I've written my date, it includes a time. So yeah, suppose we could have multiple orders from a customer on a particular date. Let's look at the other one and try and make some sense out of this order line table. You had to create an order line table. So let's look what we got going there. The order line table has an order number. So why would it have an order number? The order number, and it has a part number. This, I think, is if we go back, this order number, doesn't it sound familiar? It sounds like it comes from the orders table, right? Yeah, 608. 608. So these order numbers are the key field in the order line. So what's going to happen is that inside a particular order, the order can have multiple order lines. And we can see that here. Let's see. Yeah, see this? The same order, order 21610, has more than one order line, right? So we see that order showing up more than once. So this is not a primary key here. This is a primary key in another table, so it's a foreign key. And I don't think that we actually have a primary key here. The primary key would be what we call a concatenated key, or a key that's made up of two or more fields in the table. So in order to get a key for this, to get a unique identifier, you'd have to state the order number and the part number. Those two things together would give you a unique identifier for this row in that table. All right, so the order line is a table which can be linked to the order table by the order number. When this order number, when we look at the orders table, we see that that order number is about this order. So on this day, on the 20th of October 2010, customer 148 made an order, and that order, so that was 608, right? Yeah, only had one line. But if we go to the next order, 610, on that date, same day, different customer, that customer, their order had more than one item in it. So they had an order that had two parts. And so the first order only had one item. The next order had two parts. So actually, and it's interesting that this one is actually sorted by order number. But you'll see this when we do lab 3. We're going to have to join these tables together. When we do the joining of the tables, we're going to do that by equating, making equal the order number in one table to the order number in another table. So when the order number is 21608, that's about this order. And that 21608 means that this part number is about that order. All right, so the part number, this is the unique identifier in the part number table. So this part number, if I wanted to find out details about this part number, I could use this as an index to go and search in the part table. Let's look at the part table. So the part number, we have it here as our unique identifier. That's the primary key for the part table. So if the order included this part number AT94, then these things we know about it. It's called iron, and there's 50 on hand, and it's a class of HW, which is probably hardware, and it's found in warehouse 3, and its price is that much. So if I go back to the order line, I can see that we ordered 11. Remember, there was 50 online. The quoted price looks like it's different than the price that was in the warehouse, but it would come from warehouse 3, and its name is iron. We can't see that here. The only way we could get that data is that information is we'd have to pull it out of the part table. But we can do that by setting the part number to the part number in the part table. And then we would be able to get all these details about part number 94, AT94. And the last one's a sales rep, which is actually the first one that you created. So we only have 3 sales reps, and there's a bunch of details about them, where they live and etc. So I hope that gives you an idea about what we're working with in these set of assignments. We're working with these 5 tables. These 5 tables are related. It's a relational database. How do we relate them? We relate them through their foreign keys. We have these 2 concepts, a foreign key and a primary key. The primary key, we saw that when we created the tables. The primary key uniquely identifies every row. So this is a primary key in this table. But when we go to the customer table, the rep num shows up there too, but it's not a primary key. We know it's not a primary key because multiples are allowed. This is a primary key, customer number. Rep number is still a key, but it's a foreign key. It's a way that we use to get more data about the rep num, is that we can take this number into the sales rep table and use that as an index to find out about that stuff. I don't know if I don't want to just keep talking around in circles about the same stuff. So I'm going to sort of